amazed by that also. I shop there pretty much all the time. But yeah, I never saw you there. So let's see. What are we working on today?
Same thing as last time. I just need to go over all the reviews, make sure I know everything.
Okay, I have test 4 review. I think that's what we worked on last time.
We worked on test 1 review. We were just going to go over everything.
Well,
This was the one we did. This was the pre-calc one.
all right. I
For
don't,
trig.
I don't have test 1 review that I can pull up quickly. The only one I have in my system is test 4 review. It's the only one I've made readily available to my desktop. I don't know if we got through this entirely. I don't think we did. I don't remember doing 17 at all. But I want you to tell me what you want to work on, even if you have to resend it to me.
On that test, I got in like an 87, so I'd prefer to go over the tests I didn't get so well.
That's a good score. That's cool. So, question is where is that? The only thing I have saved on my desktop is test 4 review and test review answers. And if I go to my Gmail and look at stuff that you've sent me, maybe this one. I don't think this would be it, but no, that's a different person. I don't even know why that came up. Oh, because I requested Zachary and you got, let's see, if I look at the last file you sent me before that, I got to go all the way back to September. I don't think that's correct. So
I sent a reply in the email I sent you just now.
Okay.
And then on the first message we put
attached files.
On the first one, it was sent December 5th, 6 days ago.
Yeah, do you see it on this email anywhere?
Yeah, it's the first email. That was the reply.
Oh. Okay, now I see it. All right, which one do you want to go over?
We started test 1 review, I think, last time. So
okay, let's do that and we'll try to pick up. Wow, I wonder why that didn't show up on my history. Well, I don't actually remember doing this one. Yeah, kind of I do. And I kind of remember doing 2. And I remember doing 3. And kind of remember doing 4. Do you remember where we left off?
yeah, I think it was 7.
Yeah, I was going to say, we did 7. I remember doing 7. I do not remember, I kind of remember doing 8. But let's do 8, just for the heck of it. So tell me what f of k minus 2 is. I remember talking about this one.
Yeah, we plug in for t, we do k minus 2. So
Okay, so tell me what that is.
3 parentheses k minus 2 parentheses squared minus 2.
Okay, now you'll notice that that's not on the answer list. So you do have to expand that to see if you find it. And I remember doing this because we got none of these. Other words, when you expand that, you get this. And when you multiply that, you get this. And when you simplify that, you get this. And that was not on there. So the answer was E. All right. Yeah, I don't remember doing this one. So what the heck is the question here? What is f of 6? Is that what they're saying? No. Oh, f of minus 2. They're wanting f of minus 2. What is that?
Well, it depends which one.
Well, which one is it? Look to the domain. Is it at the top formula, the middle formula, or the bottom formula?
Couldn't it be top or middle?
Nope.
Or no, not middle.
Middle x has to be between 1 and 3. This says x is minus 2. The only one it can possibly be is that one. So plug in minus 2 for x. What do you get?
6.
Okay, good. So this line is perpendicular to that line. So what's the first thing we need to do? Very important step.
Find the slope.
Well, put it into y equal mx plus b format. If something is in y equal mx plus b, then determining perpendicular slopes is really easy. So put the first one in y equals mx plus b format. Put that one in there. What is it?
4 minus 5xy divided by c.
Good. 4 minus 5x divided by c. And now solve that one for y.
9 minus x divided by negative 3.
Okay, 9 minus x divided by minus 3. Okay. Neither one of these are in y equal mx plus b format. Convert this first one into mx plus b. What do you get?
Negative 5c.
Hold on. Do that part first. Always write left to right. Even though you're going to turn it around once you get it. It's 4 over c minus 5 over cx. Now put that in mx plus b format. You with me?
Yeah.
Okay, now do the same thing for this y.
Y equals negative 9/3.
Which is negative 3.
Plus x over 3.
Which is 1/3 x. So, if we put this in mx plus b format, we get that. So, that is the mx plus b format of the first equation. That is the mx plus b format of the second equation. What has to be true if these lines are perpendicular?
Their slopes have to be the inverse.
The inverse opposite. So minus 5c has to be equal to minus 3 over 1. In other words, I took the inverse opposite of that. So what's c equal to?
Negative 3.
No, you got to cross multiply, first of all. Now solve for c.
Okay, 5/3.
There you go. E is the answer. In other words, before you can compare slopes, this is a problem that asks you to compare slopes. Before you can really get the slope of either of these lines, you have to put it in y equal mx plus b format. Well, that's not quite ymx plus b format, but that is. That's perfect. Y, well, this one here. That's y equal mx plus b. This is y equal mx plus b. And they say the two lines are perpendicular. Therefore, the slope of one line, which is the m, has to be equal to the negative reciprocal of the other line. Well, the negative reciprocal of 1/3 is minus 3 over 1. That's got to be equal to minus 5 over c. And then you just solve that equation. All of these problems are difficult in the sense that you have to do 3 or 4 things. You don't solve them in one step, ever. We're at a point where it's like 3 or 4 steps, and you have to know all the principles involved. You have to know that you have to solve it for y in order to figure out what m is. And then you have to compare the two m's. First step, the moment I see this, what do I have to do? Forget about the first part.
You have to find like a line with the same slope.
Yeah, so solve this equation, put it in y equal mx plus b format, and you'll know the slope of it. And once we know the slope of this line, then we'll know this. It's parallel, so it's got the same slope. So what's the slope of the line that they give us? You got x plus 2y equals 7. Put that in mx plus b format.
So it'd be 7 over 2 minus
No.
y over...
No, we're trying to solve for y. When you are putting it into y equal mx plus b format, you got to solve for y. Solve this equation for y.
Okay, 7 minus x over 2.
There you go. Now put it in y equal mx plus b format. It's not quite there.
Negative x over 2.
There you go. That's negative 1/2 x. It's useful. It's more useful to write it as negative 1/2 x because that tells you what the slope is. What's the rest of it?
7 over 2.
Plus 7 over 2. So there's the equation of this line right here. Now, they want a line that's parallel, meaning we have the same slope, and it goes through that point. So we're going to use slope point. Are we going to use y equal mx plus b? What are we going to use? There's two different formats that you have a choice of.
Probably slope point.
Yeah, point slope. It's not slope point, it's point slope. You have a point and you know the slope. We know the slope is minus 1/2. And we have a point, a comma 0. So give me the general formula for point slope.
Change of y over change of x.
No, it's y minus y1 equals the slope times x minus x1. Notice that we have a slope and there's our point. So when you have exactly a slope and one point, point slope is a great format to use. So what does this convert to? We have our point, we have our slope, fill in everything into point slope.
Y minus 0 equals 1 or negative 1/2 times x minus a.
Now tell me what the answer is.
BB.
Yeah, very good. I was still searching for it. But if I distribute this, I get minus 1/2 x plus a over 2, and that is b. Okay. So the very first thing I need to write here.
Plus or minus?
When you're searching for the domain, if I said y is equal to square root of x, then my domain would be x has to be greater than or equal to 0. So this is a slightly more complicated problem, but you do exactly the same thing. What has to be greater than or equal to 0? Whatever's inside the radical sign. You cannot take a radical of a negative number. So whatever it is, no matter how complicated it is, set that greater than or equal to 0. That's how you begin. That's the first line you should write. Always. Now solve that.
Should be 9 or...
Hold on, let's solve it step by step, because this is a little different. This is a little more difficult to solve than a typical inequality. What's the first step?
Take the square root.
No, you got to isolate that first. You can't take the square root of this. There is no square root of 81 minus t squared. You got to isolate t squared first. Once you isolate t squared, then you can take the square root of it.
T squared equals negative 81.
No, minus t squared is greater than or equal to negative 81. That's the second step. Now what? Trying to isolate t squared first. How do you isolate t squared here?
Change the sign.
How do you do that?
Multiply by negative 1 to both sides.
Okay, tell me the next line.
The square root, both sides.
No, the next line is t squared. You said the next step was to multiply both sides by negative 1. So what results when you do that? I multiply that side by negative 1 and multiply that side by negative 1. What do I get?
Just get t squared is greater than or equal to negative 1.
Well, first of all, when you have an inequality and you multiply by a negative number, you have to change the direction of the inequality. So it becomes t squared is less than or equal, and that is not negative 1, it's positive 81. So here's where we're at. T squared is less than or equal to 81. Make sure you understand how we got there. If you don't, I'll back up.
No, I got it. You just need to change the sign.
Now, this is a little different. This is a little tough. How do I solve that? How do I solve t squared is less than or equal to 81? Let's assume you're going to take the square root of both sides. What's the answer?
Plus or minus 81, or 9. Jeez.
Here's the answer. Either t is less than or equal to 9, or t is greater than or equal to minus 9. Now, do you see how I got from that step to those two steps?
Yeah, the sign changed, so you had to change
The sign changes and the direction of the inequality changes. And notice why that works. Because we are subtracting t squared. So t being greater than minus 9 would be like minus 8. Minus 8 squared is 64. 81 minus 64 is greater than 0. And as long as t is less than 9, if t were 7, 7 squared is 63. 7 squared is 49. 81 minus 49 is greater than 0. So it's pretty easy to recognize that that's your solution. Obviously, if t was minus 10, this would not be true. Or if t was plus 10, that would not be true. So whenever you have this, and you're solving this by taking the square root of both sides, then it's two different answers. It's this one, and change the sign, change the sign. That's how you solve when you have to take the square root of both sides of an inequality. That's how you do it. It's the one other exception. Usually the only rule I teach people about inequalities is when you divide or multiply by a negative number, you change the direction of the sign. But square roots are a little different. When you take the square root of both sides, the first answer, you leave the sign the same. Second answer, you change the direction of the inequality and you change the sign of the answer. Notice how I went from this to this. I went from t squared less than or equal to 81 to t less than or equal to 9 or t greater than or equal to minus 9. Same process I went through over here when I had x squared less than or equal to 4. What is my answer?
Would it be A?
No. Let's put this on a number line. That's the best way to see it. Okay, there's 9. There's minus 9. There's 0. Our answer says t has to be less than 9 or greater than minus 9. There's the solution set right there.
Oh, so it'd be C?
Yes.
Or no, it'd be D. It'd be D.
Well, oh, you're right. My apologies. You are right. D is correct because it's greater than or equal. Very good. Very good. What does that first sentence mean? What does that translate to? What can I write? If the distance, the stopping distance, varies directly as the square of the speed, give me an equation I can write with just that sentence. D equals what?
The square of S.
But there's always a K. No, don't forget the K. The K is probably the most important part. There is some constant. We don't know what it is yet. But they're going to give us enough information to calculate K. Then we're going to know the true equation that governs this car. But there's always a K. Whenever you have varies directly or varies inversely, you have a K. Okay? A certain car is traveling 40 miles per hour, can stop in 52 feet. So tell me how that's going to allow me to solve for K. All of these problems with direct proportion and inverse proportion, they follow the exact same pattern every single time. You write the generic formula from the first sentence, you solve for K with the second sentence, and then you have the specific formula and you can solve for D once you know K, but you got to know K. K is the most important thing here. So how do I solve for K from the sentence that I've underlined?
You take D and divide it by, divide by S squared.
Hold on. What's D? In the sentence that I've underlined, what is D?
It's 152 divided by 40.
No, it's just 152. It can stop in 152 feet. That's the stopping distance. That's equal. We don't know K yet, but we know 40 miles per hour squared. So 40 squared. Now you can solve for K. Tell me what K is using your calculator. It's 152 divided by 1600. It's that number. What's 152 divided by 1600?
I do not know. I can calculate this.
You always need a calculator in front of you when we're doing sessions, Zach. Always.
It's 0.095.
Okay. So now tell me the specific equation that applies to this car and these brakes. What is D equal to? What is the stopping distance going to be equal to? The only thing you have to do is plug in K to that equation.
0.095 times 65 squared.
No, times that. That is the specific equation. This is the general equation. D equals KS squared is the general equation regarding just their first sentence, that it varies directly as the square of the speed. That's what that means. But then they give us a second sentence that allows us to calculate K, and now we have a specific equation for this car and these set of brakes. And now that we have a specific equation, we can answer their third question or their third sentence. They want to know, what is the stopping distance for the same car traveling 65 miles an hour? So how am I going to answer that?
It'd just be 0.095 times 65 squared.
Okay, give me a number. Carry it out to at least one decimal point. They want us to round it out to the whole foot. And in order to do that, we're going to need that second, we're going to need it to one decimal point.
401.3.
Hold on. Square 65, multiply it by 0.095. What'd you get?
401.375.
What's the answer?
Just 401.
Yeah, D. All of these problems are exactly the same. Every one of them that involves varies directly, varies jointly, varies inversely. For example, if I said that y varies inversely with x, what's the formula?
K times X.
K over x. I said inversely. It would be k times x if it was directly. Now if I said y varies inversely with the square of x, what would it be? Y varies inversely with the square of x.
So it'd be K over X squared.
Good. Now what if I said y varies directly with the square of x?
K times X squared.
Okay. Now if I said y varies jointly with x and z.
It'd be K times Z plus K times X.
Actually, they're multiplied. Jointly means multiply. But notice every one of these has a k. K is the key thing. You can't forget the k. And every one of these problems that I have ever seen, the first step is to write the general equation. The second step, you calculate k based on the second sentence they give you. Always. I've never seen one vary. They give you the first sentence that lets you write the general equation. They give you the second sentence that lets you calculate k. And then once you have a specific equation, you can answer the third sentence. And they're all that same way. I've never seen one different. The only difference might be that instead of varying directly, it varies inversely. Inversely means the variable goes in the denominator. The k always goes in the numerator, always. Whether it's varying directly, inversely, or jointly, the k goes in the numerator. All right, I only see one way to do this problem, and that's kind of the hard way. Not really. What is f of x squared?
It'd be X squared plus 8X plus 4.
Plus 16. In other words, you're squaring that. What is this? What is f of x squared?
Just be X squared plus 4.
Now solve that.
So it'd be 8X plus 20.
Actually, I made a big mistake when I wrote it. Forgot to put the parentheses in. Notice why that changes it. This says minus f of x squared. That is f of x squared. So I have to subtract the whole thing. I can't just subtract x squared plus 4. I got to subtract the quantity x squared plus 4. Now redo the simplification. What do you get?
Eight X plus 12.
Big difference. One is the correct answer, the other is not. And the key here is recognizing that I'm taking that and I'm subtracting that. So whenever you're subtracting a function, make sure you put parentheses around it. It really is important. In fact, I should have done this. I should have put parentheses around that. That is f of x squared. And f of x is this. Or, excuse me, f of x squared is that. Without the parentheses gives me a different answer than with the parentheses. And I definitely need the parentheses because I am subtracting f of x squared. That is f of x squared. I am subtracting the whole thing, not just the x squared part. So for sure, that's the answer. Give me the formula for the slope between these 2 points. First of all, what is slope? Definition?
Change of y over change of x.
Okay, I like that. I prefer rise over run. The only reason is that I know that 10 years from now you will learn rise over run. Hold on, I got problems here. It's not letting me write. Hold on, how am I going to solve this? Yeah, let's close that out. Test 1. It's not even letting me close that out. That's never a good sign. Okay, now we're in good business. Let me open that back up and go down to that problem and see if I can take a snapshot of it. It's 15, I believe. And needs to be expanded a little bit. And need to take a picture of it. So tell me what the slope of that line is that connects those 2 points. Dad, okay, this is the way I prefer you remember it. Rise over run, always. That's where you start. The rise is the change of y divided by the change in x, which is y2 minus y1 over x2 minus x1. So what's the slope of that point? Plug it directly into that. What's y2? That's y2. That's x sub 2. That's y sub 1. That's x sub 1. Now plug it directly in.
9 minus 4 over negative k minus k.
Okay, that's the best way to do it. Now let's simplify that. Because we don't see that answer on anywhere. What is that?
Just 5 over 2k.
5 over minus 2k. In other words, minus k is minus 2k. along and hope to do well. That's simple algebra 1. Minus k minus k minus. They're telling us that that slope is equal to 3. So now solve that for k. That's the first step.
Multiply. Actually, wait now.
No, you're right. You got a denominator. Let's get rid of that denominator. How do I get rid of it?
Multiply both sides by -2k.
Okay, what do you get?
5 equals 3, or -6k.
Now solve for k.
-5/6.
Answer C. It's a piecewise function. They want the y-intercept. What's x going to be on the y-intercept? Always. By definition, what is x going to be on the y-intercept? When I have a function that's on the y-intercept, what is the value of x?
0.
So which of these three functions are we going to use? Top, middle, or bottom?
Middle.
Where is x 0?
Oh, so we use the top one. Okay.
No. Top one only applies when x is less than -5. Where is x 0? Top, middle, or bottom?
Oh, bottom.
Okay. Plug it in. What do you get for the square root of 9?
3.
That's the answer. And notice that it has the x and the y coordinates. So it's 0, 3. But notice that all 5 answers have 0 as the x coordinate, because that's the definition of the x coordinate when you're looking at y-intercepts. When I'm looking at x-intercepts, what's the y coordinate? When I'm on an x-intercept, what's the y coordinate? If I'm on an x-intercept over here, what's the y coordinate?
Just 0.
If I'm on an x-intercept over here, what's the y coordinate?
0.
So x-intercepts always have a y coordinate of 0, and y-intercepts always have an x coordinate of 0. What the heck? This looks like the same problem. Find the y-intercept, find the x-intercept. Okay, it's a little harder, quite a bit harder, because right offhand we don't know which equation to use. In other words, we know the y coordinate is 0, but we've got to figure out which piecewise function to use. We got a choice of 3. So where is the y coordinate 0? kind of have to solve these, I think. Solve that. In other words, this is quite a bit more difficult problem. Solve that. Where is y equal to 0? We got 0 equals minus 3x plus 5.
Should just be 5/3.
So that's one place that y equals 0. What's another place? Do the second one. Set y equal to 0. Solve that.
I could do square root of 8.
It's plus or minus. Not negative. Move the 8 to the other side, it turns positive, and then you got x squared equals 8, which means x equals plus or minus square root of 8. So that's where y is 0 in the second piecewise function. Now let's do the third. Tell me what x needs to be. Solve this equation.
Be 9.
Minus 9. In other words, if you square both sides, you get 0 equals x plus 9. Therefore, x has to equal minus 9. And y equals 0 because we set it equal to 0. So, there's my 3 solutions. 5/3 plus or minus square root of 8 and minus 9. Let's see if we find that. 5/3 minus 9 plus or minus square root 8. There you go. That's the answer. Notice how much harder this was. We had to actually solve each piecewise function setting y equal to 0. Why did we set y equal to 0? Because we were talking about x-intercepts. Y is always 0 on x-intercepts. So all we have to do is find the value of x for each of these functions whenever f of x is 0. Remember, y is the same as f of x. So you just substitute 0, solve each one of them, you come up with actually 4 answers, and that's D. These are not trivial at all. These are all fairly tough. Some of them are easier than others, but nothing easy about any of these. What happened here? Click on that, see if that matters. Let me try it again. Trying to take a snapshot of the screen. There we go. Okay. Now, average rate means what? That's what slope means. That's what slope is. First derivative is instantaneous rate, but slope is average rate. So they want the average rate from t equal 4 to t equal 10. So what is it? Here, let me write it like this. It's f of 10 minus f of 4, all divided by 10 minus 4. Notice that's the rise, that's the run. That's the average rate of change, is slope. The rise over the run. Now, do you see why this is the rise? That's the two y values, f of 10 and f of 4. The run is the difference in the times, 10 minus 4. So what is this? What's f of 10?
$13 minus 3. So it'd be 10 over.
Hold on. Do not drop negative signs. What is f of 4?
Minus 3.
You dropped a negative sign. I was going to give you the wrong answer. All over what?
All over 6.
What's that?
Should be 16 over 6.
Which is 8/3. You cannot drop negative signs. For some reason, everybody loves to do it. It's one of the biggest mistakes I see in my students, is they love to drop negative signs. I can only assume it's because everybody hates negative signs, because they don't like dealing with them, and so they're really anxious to drop them. Unfortunately, you get the wrong answer if you drop exactly one negative sign. You have to take f of 10 minus f of 4. Well, f of 10 is 13 minus f of 4 is minus 3. You cannot drop that negative sign. That now becomes a minus of a minus, turns it into 16 instead of 10. So you're always going to get the wrong answer if you drop a negative sign. Just remember, do not drop negative signs. It will definitely give you a wrong answer. Nobody adds negative signs. Everybody drops them. So I find interesting. I don't quite know why. Everybody drops them. Nobody adds them. They don't like them, so they drop them. You see a negative sign, you don't like it, you forget it. You don't put it in. All right, so how do I vertically shrink that function? By a factor of wow, doesn't tell us. Just says we vertically shrink it. Do I have to put a number greater than 1 or less than 1 in front of the square root of x? To vertically shrink it.
Well, one that's less than?
Yeah, it has to be less than 1. In other words, this would work. That would be a vertical shrink. So would this. This would not. This would be a vertical stretch. So the number in front of the function, the elementary function, has to be between 0 and 1. You couldn't even say negative 1/2. That wouldn't be correct. Well, maybe it would. But definitely it's a number between 0 and 1 in this case. Okay, so it can't be that. It could be either one of these or something else. As long as the number in front is between 0 and 1, then it's vertically shrinking it. Now, shifting it up 20 units means what? How do I vertically shift it up by any amount?
You add 20.
Okay, so let's take both of my examples. That would suffice as an answer. That would suffice as an answer. Of all the answers you see on there, which one does suffice? This does
C.
not, because the fraction in front of it is greater than 1. So that's a vertical stretch. This doesn't make any sense at all. This doesn't make any sense at all. This is perfect. This number is less than 1, greater than 0, and we're adding 20 to the result, which is a vertical stretch. So C is clearly correct. They do add a degree of difficulty to these that is interesting. In other words, they don't tell you that it's vertically shrunk by 1/2 or 1/3. They just says that it's vertically shrunk. Which means you have to know that it's a number between 0 and 1. We doing 2 hours today? Is that?
Yeah.
Okay. Ooh. 20 is tough. Let's try to find a function whose domain is that. What function would the domain equal that? This is not the easiest thing to do, but this is the only way I can think of doing it. What kind of function would be restricted from -8 to 12? What has to go in there so that it would be restricted to -8 to 12? Wow. Hold on a second. Man, that's not going to be very easy. Let me think about this for a second. Let's take another function. What's the domain of that? Oh, excuse me, y equal. How would I figure out the domain of that? X has to be what? X minus 2, x minus 2 has to be greater than or equal to 0. So what does x have to be?
2 or greater than 2.
There's the domain. Now, if I said to you, what is the domain of 1/2 y? Well, 1/2 y would be this. Has the domain changed? Wow. No, it hasn't. In other words, the domain restriction is still x minus 2 has to be greater than or equal to 0. So it hadn't changed it a bit. So far, I'm not making progress. Let's think about this in a different way. Well, if I was trying to figure out the domain of this, I would have to say 12 minus x squared has to be greater than or equal to 0. Minus x squared greater than or equal to minus 12. X squared less than or equal to 12. X less than or equal to square root of 12, or x greater than or equal to negative square root of 12. Make sure you understood exactly what I did there and why. Because clearly from the problems we've looked at, you have to be able to do this. You have to be able to solve an inequality when you have a square. So, if I said 1/2 of x, again, the domain would not be affected. I still have 12 minus x squared has to be greater than 0. So to me, that has no effect on the domain. But x minus 3 does. Let's go back. Make it simpler. We'll make it like this. We know the domain of x has to be greater than or equal to 0. Even if I say 1/2 of f of x, doesn't change the domain. But if I say y of x minus 3, well, that makes it x minus 3. Now that does change the domain. The domain now has to be greater than or equal to 3, not 0. So whatever the domain restrictions are of the original function, the new domain restrictions has to add 3 to it. So my original domain was minus 8. Therefore, my new domain is either that or that. It's the only one where I add 3 to it. Well, even if we can't find the answer, at least we have a guess between 2 choices and not between 5 choices. So we've made progress. Now, the y coordinates. Let's see. The y coordinate here is negative 1.5 times the x coordinate, right?
Mm-hmm.
So what is negative 1.5 times the x-coordinate there? Or times the y-coordinate? It would be minus 9. Whereas negative 1.5 times the y-coordinate there would be 18. Wow. Maybe one I got to come back to tomorrow. Not sure totally how to do this. I know how to find the domain, but that doesn't allow me to find the... Why are they giving me a domain? Ah, minus 5 to 6 is what that means. It doesn't mean minus 5 comma 6. It means the domain goes from minus 5 to 6. This is the answer right here. Do you have answers on it? Let me explain a little further. I know that's the answer. Here's the thing. This affects the x-coordinate of the domain only. So I have to add 3 to the x-coordinate. Gives me either that or that. This affects the y-coordinate only. So if I take half of 12, I get 6. That's the answer. This is a tough problem. This took me a few minutes to figure out. But almost certain that's the correct answer. And this is a tough question. I might spend 30 minutes working with you on this and make no progress. This is a very, very tough question. This has to do with what affects the domain and what affects the range. This is really a question about domain and range, I think. The thing is that, let's say my function was f of x equals square root of x. Well, obviously adding the 1/2 in front doesn't affect my domain at all, right? My domain is restricted totally by that. So the 1/2 doesn't affect the domain, but the minus 3 does. That means my domain has to be 3 higher than minus 8. Well, that's either minus 5 or minus 5. Now, the 1/2 is a vertical shrink factor. Well, if you think about it, vertical shrink is the same as affecting range. And the range, which did go to 12, is now only going to go to half that, 6. Do you have answers on these?
Yeah, there's
We do. Here, let me pull them up. Number 20, test 1. I think I have.
C.
C is the answer?
Yeah.
Well, I really got to rethink this then. All right. We'll come back to this once I figure it out. I haven't figured it out yet. I was sure that it was A. I'll figure it out next time and tell you why it's C. In the meantime, let's go on because I don't want to waste the whole session on me trying to figure out the answer. So I try never to do that, especially if I have a session with you tomorrow where I can give some time and thought to the question and try to come up with why it was C. So this question is a lot easier. It's merely saying, what do you have to do to this graph to turn it into that? It's not that easy, but it's a lot easier than the last one. What's the negative sign mean?
It's
Reflection across which axis?
the y-x, or no,
Yeah,
no, the x.
the x. So there's two possibilities. What's the 2 inside the parentheses mean? First of all, inside the function means it's a horizontal something. It is
So
not a vertical something. It's a horizontal what? Shrink or stretch?
Stretch.
No, it's the opposite of vertical. If vertical is greater than 1, it's a stretch. But if horizontal is greater than 1, it's a shrink. So now we're looking at shrinks only. That's the only shrink I see with the x-axis. This is a stretch. So we have a shrink horizontally, which comes from having that number be greater than 1. And we have a reflection on the x-axis, which comes from that negative sign being in front of the function, making it a vertical. Always remember that these transformations, the most important thing you can remember is that any transformation outside the function is vertical. Any transformation inside the function is horizontal. So if my function is that, I'm going to give you some examples of it, and you tell me whether it's vertical or horizontal.
Vertical.
By what? The vertical,
By 2.
is it a stretch or a shrink, and by how much?
It's vertical by 2.
Vertical stretch by a factor of 2. In other words, because it's vertical, and that number is greater than 1, it's a stretch. Now, if I change it, what's that? Is that horizontal or vertical?
Horizontal.
And what is it? Stretch or shrink?
Shrink.
By a factor of 2. So what is this? Vertical or horizontal?
Vertical.
Correct. It's not inside the function. It's outside the function. In fact, I could write that if I wanted as 1/2 square root of x. And now is that a stretch or a shrink?
It's a shrink.
Good. Perfect. There's only 6 transformations. There are 3 vertical and 3 horizontal. So the very first thing you should do is whether it's vertical or horizontal. And then figure out the rest of it. Wait. So what can I say? about that and that. Can't I say that 7 equals h of minus 4? And do you see why I can say that?
Because -4 is the x value?
Yeah. In other words, is the t value. And h of t is 7. So this is true as long as they say that point is on the curve. So which point must be on this curve? Well, the only thing that affects the y is the stuff outside the function, right? In other words, the only thing that affects the vertical is outside the function. So what does y have to be? If I'm starting at 7 and I'm subtracting 2.
It's 5.
Okay, so that's our only possible answer. Now, well, I understand that's our possible answer also. But of the first 4, we know y has to be 5. Now the question is, what is h of minus t? If h of minus 4 is 7, what is h of plus 4? Wow. Again, I may have to defer on this one. I got to think of a way to do these. No, I don't. That means a horizontal reflection, right? If my minus sign is inside the function, then it's a horizontal reflection. Well, if I make a horizontal reflection of that curve, I get this curve. In other words, h of minus t is the same as h of t. So if h of t was 7, then h of minus t is still 7. 7 minus 2 is 5. So the y-coordinate is 5, and the x-coordinate is 4. In other words, the x-coordinate was minus 4 there. So the x-coordinate of minus t is minus minus 4, and we get C. Is that the answer for 22? These are hard enough that I want to check the answers just to make sure I'm not making a mistake, like I did make on 20.
Yeah, test C, yeah, C.
Yeah. This a little tricky. But again, all right, these are a little easier. These are a little more straightforward as to stuff that you learned in high school. First of all, what's a better way to write that? How about f of g of w? That's what that means. Those two things are the same. F of g of w is the same as f of g of w. Fog of w is f of g of w. Now, let's improve this. What is G of W?
Just W squared minus 4.
Okay, now what is F of W squared minus 4? Plug whatever's in the parentheses into that.
So it'd be 5 minus 2W minus 4.
Root of 5 minus 2 times x squared minus 4.
Why is it x squared minus 4?
Because I'm plugging in, or W squared, excuse me. In other words, if G of W is W squared minus 4, so all I'm doing is substituting for G of W. G of W is W squared minus 4. So that's how I get to that step. And now, to get from this step to the step below, I got to plug in W squared minus 4 into the F function wherever I see W. If I told you that that's the F function, and I said, what is F of 2? You'd plug in 2 for W, correct?
Yep.
Well, if I say, what is F of W squared minus 4? You plug in W squared minus 4 wherever you see W, and that gives us this. Now, let's simplify that. 5 minus 2W squared plus 8. What is our answer? A through E.
It'd be E.
You simplify that, you get that. Any questions on that? It's a pretty standard type question where this is called a composite function. Whenever you see fog or goff or f of g or g of f, those are composite functions. And the best way to do composite functions is this step first, this step second, because you know what g of w is, and then this step third, because you know what f of w is. So you're going to plug that in wherever you see w. And then once you get down to here, you just have to simplify it. And once you simplify it, you get the answer you see on the page. These are definitely college algebra problems. They're probably not problems you ever saw in high school. You wouldn't see problems this tough, even in PreCalc. Kind of what's happened is that before they let you take calc, they want to make sure you can do algebra 3. And this is algebra 3. This is not algebra 2. This isn't even PreCalc. You probably never got this degree of difficulty in high school. This is not yet calculus, but it's hard precalculus. It's hard algebra. It's algebra 3. But they probably want you to take this and pass this before you go on and take college algebra, or excuse me, college calculus, which I assume is up next if you pass this course. Is that correct?
I don't know.
Okay.
Because with my I'm looking at changing my major from engineering to like criminal justice.
Okay. So you
So
may
I don't
not
know what.
end up having to take calculus.
Yeah, I don't know what the math requirement is.
Well, that's fine. We won't be thinking about calculus. We'll just be thinking about hard algebra, which is what these are. Let's talk about odd and even functions. Even functions. Wow, where'd that thing come from? Hold on a second. I'm supposed to take a screenshot, and it added something to my screenshot. There we go. If you have an even function, what that means is that f of minus x is equal to f of x. If you have an odd function, it means f of minus x equals minus f of x. Okay? Let's take the function y equal x squared. Is that even or odd? In fact, let me write it as f of x equals x squared. Is that even or odd?
Even.
Correct. Because f of minus x is minus x quantity squared, which is x squared. So f of minus x is equal to f of x. Satisfies that. So x squared is even, and one way to remember it is that's an even number. F cubed is odd. Notice why. If I say f of x is equal to x cubed, what is f of minus x equal to?
Negative x.
Negative x cubed, which is minus f of x. Make sure you understand why that's true. That makes this odd. And it's easy to remember because that's an odd number. So x squared is an even function, x cubed is an odd function. Okay? Now, let's look at even functions for a moment. Y equal x squared is a parabola. What do you notice about that parabola? What kind of symmetry does it have?
It's 1-to-1.
It's symmetric about which axis?
Y.
Okay. That means if I had a value of minus 4 and a value of plus 4, they're going to give me the same y value, right? In other words, minus 4 gives me that y value, plus 4 gives me that y value. They're the same y value. So this is an even function. All even functions are symmetrical with the y-axis. So when x is minus 6, it's 7. Well, when x is plus 6, it's also 7. Because it's an even function. And that's the most important thing to remember, is that even functions are symmetrical about the y-axis. Let's take an odd function. Y equal x cubed. Looks like that. That's f of x equal x cubed. What kind of symmetry does that have? Symmetry about the origin. It's not symmetrical with the y or the x-axis. It's symmetrical about the origin. And what that basically means is I take the top half of the function, I reflect it over the y-axis, again over the x-axis, and I get the lower half of the function. So symmetry about the origin means two reflections over the x and the y. So let's change that problem and make it odd. Now, what is this? If one number a equals y, then what does negative a equal?
Negative y.
Negative 7. So if it was an odd function, then that answer would be negative 7. If it's an even function, it's positive 7. And it's all about symmetry. Even functions are symmetric about the y-axis. Odd functions are symmetric about the origin. And there are no functions that are symmetric about the x-axis. Notice for something to be symmetric about the x-axis, it would have to look like that. Well, that's not a function. That does not pass the vertical line test. So it's really impossible to be symmetric. It's impossible for a function to be symmetric about the x-axis. It's no longer a function. This is a relation, not a function. That's a parabola that I can define with an equation, but it is not a function. So the only two kinds of functions that really you want to differentiate between are even and odd. And it's important you know even is symmetric about the y-axis. Odd is symmetric about not the x-axis, but the origin. When is your test?
Tomorrow afternoonish.
After our session?
Yeah.
Okay. So it gives me a chance to review number 20. Okay, let's look at this one here.
There's no short responses on our test.
Okay, so we don't need to do these?
I don't think so.
Okay. Look at number 2, just for old time's sake. Recognize anything? What does f of t plus h minus f of t all over h look like?
It's the derivative, but not the power rule thing.
Very good. It's the derivative. The definition of first derivative, only it's you take the limit of that as h goes to 0. But this question is not really a calculus question, number 2. That's all you have to do is figure out what f of t plus h is to solve it. So it's kind of the first part of calculus. In other words, there's a reason number 2 is on there. It's because they want you to be able to figure out what f of t plus h minus f of t all over h is. It's not that hard. You just have to go through and define what f of t plus h is. All right, so In your opinion, should we skip the short response practice and go on to the next review test?
Yes.
Okay. I'll do whatever you want to do. I don't really know what the best step is, but like I always do, I let you direct. You're the one that knows this stuff better. By that I mean knows what's most likely to be on the test. Ooh. Okay. Okay. How do you find what's q to the minus 1 of t mean? What does that mean? Does it mean 1 over q of t?
No, it means the inverse.
It means the inverse, exactly. So here's my function, y equals c over 4t minus 1, with c being a constant. Now, how do you get the inverse of that?
You just
2 steps.
bring the bottom up.
Nope, nope. That's the reciprocal. Do not confuse inverse with reciprocal. The way you solve for the inverse, it's a 2-step process. You switch the variables and solve for y. That's it. So when I switch the variables, I get this. You with me?
Mm-hmm.
Now solve that for y. That's going to be our answer. In other words, this is just an algebra problem. Know that c is a constant. So your answer is going to have c in it. But we need to solve that for y. How do you solve that for y?
Multiply both sides by 4y minus 1. And then
4y minus 1, the quantity, times t, equals c. Now solve for y.
Divide by t.
Okay, it gets rid of the t. Now keep solving for y.
And add 1.
Okay, gets rid of that. Keep solving for y.
Divide by 4.
Okay, and I can do this. I just divided both sides by 4. That's my answer. Now, let's see if we got anything up there that looks like that. Well, yes, we do. Here, let me erase some of this stuff. This is what we came up with. And we're trying to see if that equals any of our multiple choices. So, simplify that. First of all, how can I add those two fractions together? If you had to guess without doing any more math, which one would you guess? I've got a 4t in the denominator. That ain't going away. Which one of these answers has a 4t in the denominator?
C.
Okay. Now, let's see if that's the same answer. Add these two fractions. What do you get? What's the common denominator?
4T.
The numerator over there is C. What's the numerator over here?
T.
So that's equal to C plus T all over 4T. That's this answer right there. Okay? So finding inverses is really rather easy. It's two steps, and I always do them in this order. First of all, I change Q of T to Y. Just makes it more understandable. Whenever you have f of x, you can use y. Whenever you have g of x, you can use y. Whenever you have f of t, you can use y. Once you use y, then you get y equals c over 4t minus 1. Switch the variables, switch y and t, and then solve for y. So it really is just an algebra problem. In other words, once you do that, you get t equals c over 4y minus 1. Now, that's an algebra problem. It's not that difficult of an algebra problem, but it's still just an algebra problem at this point. And the only thing that, if I solve for y, I get this. I don't know how else to explain it. But that's what inverses are all about. Switch the variables and solve for y. You scheduled a 2-hour session just because your test is tomorrow and you wanted to get 3 hours in before your test?
Yeah.
Okay. 2-hour sessions are tough. I would imagine your brain is getting a little scrambled by now.
Little.
Yeah, everybody's does. To do 2 hours straight of math is hard. Really hard. For anybody, me included. My brain is getting a little scrambled by now. Sometimes I got to do 5 hours in a row. You should see me by the 5th hour. I can barely add 2 plus 2. All right. There's one thing that you need to know about inverse functions. The domain, I'm going to have to close this out, open it up again. It does not like me trying to do that. Definitely didn't like me doing that. Hold on a minute. Okay. If I say that f of a equals b, then if I'm talking about the inverse of f, then I know this is true. When you're talking about inverse functions, you switch the domains and you switch the ranges. So if I told you that f of 1 was equal to 2, then that means that f inverse of 2 is equal to 1. That's simple. That's straightforward. So, to answer this question, if g of 4 equals 30, means that when the water is 4 inches deep, you have a volume of 30 ounces. What does the inverse g of 50 equals 10 mean? Don't look at the answers yet. Most of these problems, it doesn't really do you any good that it's multiple choice. You kind of have to figure them out and then search for the correct answer from the multiple choices. But think about what this first one means. 4 inches depth means 30 ounces of water. So what does this mean? Switch the two.
Ten inches gives you 50 ounces.
Perfect. In other words, it's just the opposite of this. This would mean that g of 10 was equal to 50. And that means when it's 10 inches deep, it's 50 ounces. So by giving us the inverse, we know this is the ounces, this is the inches. So we have a function. Oops, hold on a second. Boy, it's really starting to give me problems on taking snapshots of these. I wonder why that is. There we go. Now let's make up a function. When x is 8, f of 8 is 11. That's what that says. Okay? Is that a one-to-one function that I've drawn?
No.
No, not really. It was up to that point, though. If I talk about just the function from here to here, it is one-to-one. I screwed up with this part of it over here. But, okay, I can change that easy enough. Let's make the rest of that look like this. Now it's a one-to-one function. Okay? In other words, that's the first thing we have to satisfy. So we have to make it one-to-one, which means it has to pass the vertical line test and the horizontal line test. So which of the following cannot be true? Well, that could certainly be true. All I got to do is draw the function like this. And f of 11 is 8. So that could certainly be true. So that's not the answer. f of minus 8 equals minus 11. I'm just going through all the ones that can't be true. Well, f of minus 8 being minus 11 could certainly be true if I drew the thing like this. Still a one-to-one function. So my blue line is my function, and yet that's true and that's true. So those can't be answers. So my answer is B, C, or D. Now, can f inverse of 11 be equal to 8? Talk about inverses again. Graphically, the inverse of a function is always the reflection over the line y equal x. Okay? So that's the line y equal x. And the inverse, let's say my blue line is what we think the function is. Okay? So now let's look at the inverse. Could that be true? If f of 11 is equal to 8, could f inverse of 11 be equal to 8? Well, if I draw the inverse, I'm reflecting across that line. Not a really good artist, but nonetheless, that suffices, I think. Could f of 11 be equal to 8? Yeah, looks like it. Looks like that could easily be true. And this can probably be true. This is a whole different story. If f of 11, no, I'm wrong. I'm wrong. Answer me this. What does f inverse of minus 8 have to be? By definition. Excuse me, f inverse of plus 8. What does that have to be? $11. In other words, you merely switch the domain and range. 11 was the domain, 8 was the range, and if I'm talking the inverse, then f inverse of 8 equals 11. So that is a true statement.
Then E would be true too, right?
Why? Well, we know that f inverse of 8 is equal to 11. It doesn't allow us to eliminate anything. Which one cannot be true? Well, that one can be true, and I'll tell you why. Ooh, maybe. F of 11 equals 8 could be a straight line like this, where that's 11, that's 8, right? Now, the inverse of that has to be a reflection over the line y equal x, which looks like that. And if I reflect that green line over y equal x, I get this. And now f inverse of 11 can't possibly be 8. So that cannot be true. You check the answer on this one just so I don't have to think about it when I'm going to bed tonight. Number 3 on test 2.
D.
D. Can't be 5. Yeah. I'm going to have to investigate this one further also. So number 20 and number 3, I will look at between now and tomorrow and see if I can figure out why the answers are what they are. Trying to figure out how could f of 11 be 8 and f inverse of 11. All right. Okay, now I get it. I understand why I was wrong. In other words, if f of 11, let's draw the inverse line on there. But if I had a function that was something like this, where f of 11 was equal to 8, and notice that if I reflect that function over that line, I get this. Well, I still got f inverse of 11 equals 8. So that is possible. So is that. Haven't yet figured out why that's impossible, but I will between now and tomorrow. Zach, I'm exhausted. I'm sure you must be too. Although you're probably used to this. A younger person can do 2 hours of math much easier than an older person can. So we'll pick up with your session tomorrow.
Okie doke.
Talk to you tomorrow. Bye-bye.
Thank you.